Hi students, this is lesson 8.2 and this is using the sum and difference identities. So we will be evaluating trig functions, trig expressions rather, using the sum and difference identity. So let's go ahead and get started. We are on page 5 in your packet and we are going to write down the sum and difference identities for both sine and cosine. So, and I'm going to actually write, let's see if I can fit this in here. I'm going to do it right here instead. Okay. So if I have the sine of some value plus another value or minus, those are two separate situations. The way that we evaluate this is we can take the sine of that first term times the cosine of the second term, and then we will add if we started out adding, okay, we'll keep that addition there, and then we will subtract if we started out with a difference, and then we have the cosine of A times the sine of B. So if we start out with sine of a sum or a difference, we can go ahead and use this identity to evaluate. Okay, let's go ahead and take a look at the cosine. So if I have the cosine of a sum or a difference of terms, the way that we evaluate this is we're going to say the cosine of the first term times cosine of the second term. If it was a plus sign to begin with, we are going to subtract. And if it was a minus sign in the beginning, we are going to add. Oops. Okay, so cosine of the first term times cosine of the second term plus or minus, depending on the situation, sine of the first term times sine of the second term. So we're going to practice this, but again, you're going to start out with a sum or a difference, and you're taking the sine or cosine, and then we're able to use these identities. So let's continue on. Let's take a look at something from page 6. And this is letter A. So this is asking us to evaluate the cosine of 2/3 pi minus pi over 4. Now we could certainly subtract these and get a single value, but what usually will happen is we're going to get a value that we don't know from our special right triangles. If we want an exact value, it's going to really help if we can break this apart into these special right triangles. Okay, so just as a refresher, keep these somewhere where you can take a look at them. If you get a little rusty here with these special right triangles, very important. 1/2 and radical 3/2 and 1. Okay, so first of all, we have to know that this is taking the cosine of a difference. And so we go ahead and we use our formula. So if we look back at our formula page here, our identities, the cosine of the difference means that we're going to use this addition sign right here because it's the cosine of a difference. So let's go ahead and set this up. So we would say the cosine of A, so this is our A and this is our B for the terms. So cosine of 2/3 pi, okay, times the cosine of pi over 4. We don't use that minus sign. It's not a negative pi over 4. The minus is the difference of the two terms. Okay, we're going to say plus, because we have to match up, because it's a minus sign to begin with, and in this identity, it's a plus sign here. Sine of A, which is 2/3 pi, times sine of B. Okay, so let's go ahead and find out what these values are. So cosine of 2/3 pi. Let's think about where we are in our unit circle. We're right here. It's going to have a negative value, And of course, my reference angle is that pi over 3. So this is going to be a negative 1/2. And then cosine of pi over 4, that's going to be in the first quadrant here, which is going to be a positive radical 2 over 2. Plus sine of 2/3 pi. So again, here's my 2/3 pi. This is going to be positive. I'm in quadrant 2 for sine. And again, 1/3 pi is my reference angle. So the sine of this is radical 3 over 2. Sine of 1/4 pi, again, I'm still here, pi over 4 in the first quadrant, and that is a positive radical 2 over 2. So this becomes negative radical 2 over 4 plus radical 6 over 4, and I can actually combine those fractions with the same denominator. So I can put that all over 4, and this is my answer. Now, if you go ahead and type this in, what I'm going to do is I'm going to type in the original. So I'm going to type in cosine, then it gives me a parentheses. I'm going to do 2 pi divided by 3, and then minus pi over 4. Okay, and let's see what we get here. So I just got approximately 0.259. Okay, that's when I plugged in this original. Okay, and this is obviously, it's an approximation. But let's see when I plug in down here, if I were to substitute that negative square root of 2 plus the square root of 6, and then divided by 4, and I get approximately 0.259. So these should match. The difference is when I use this method, I get an exact value. And a lot of calculations require us to keep exact measurements until the very end. So that's why this is used in terms of precision. We can get those exact values. All right, let's look at the next one, letter B, sine of a sum. Okay, sine of a sum, here we go. That's this top one, a sum of terms. We're going to use this plus sign in this identity. So again, we have A and B. Doesn't matter which is are just two terms being added together. So we just use the first one as A, the second one as B. And so from here, we'll go ahead and say sine of A times the cosine of B plus, that's the identity because we started with a plus here, a sum of terms, cosine of A, which is 5/4 pi, sine of B, which is pi over 6. Okay, once again, we're going to evaluate all these little tiny ones and see where we go. So 5/4 is here, 5/4 pi. And we know that our reference angle is at pi over 4. So in quadrant 3, sine and cosine are actually both negative. So this is negative radical 2 over 2. And I'm just going to fill in what I know since I'm right here. These are both the same. Okay, the next thing we want to look at is pi over 6. So that's this guy right here, pi over 6. So when we think of that, of course, pi over 6 is my reference angle. And again, if we need to draw this out, we sure can. Okay, and if we're doing the cosine of pi over 6, we get radical 3 over 2. And if we do the sine of pi over 6, we actually get 1/2. So let's continue on. I get negative radical 6 over 4 plus negative radical 2 over 4. And I can go ahead and combine those fractions. Negative radical 6 minus radical 2 all over 4. Again, this is an exact answer. If you were to put this in the calculator and put this in the calculator, you should get the same decimal approximation. That is your sanity check to make sure that you did it correctly. Okay, now with this next part, this is page 6 towards the bottom. So here's what we're really getting to. I have cosine of pi over 12. Well, I don't have a special right triangle in my head that has pi over 12 as an angle. It doesn't mean it doesn't exist, but we only have those two special right triangles. We're not going to memorize every single possibility. So if I could break this up into two pieces that can be added or subtracted to equal pi over 12, I could use the property, okay, that identity. So let's think about this. Pi over 12. It has to equal this. Two things that if I add them together or subtract them, I would get that value. So let's think about if we broke this into twelfths. So what if I did 3/12 take away 2/12? Now that is 1/12. That makes sense. Did I help myself or not? Let's see. 3/12 is the same as pi over 4. Hey, that's a special angle. I know that one. 2/12 pi is the same as pi over 6. Hey, I know that angle too. Both of these angles are in my special right triangles. So this is very helpful. We could have, don't write this down, we could have done this. We could have said, let's say 11/12 pi, take away 10/12 pi. This one reduces to 5/6. That's helpful. This one doesn't do anything for me, right? So we're kind of still stuck. The difference is still 1/12 pi. It's correct. The subtraction is right. But we want to pick something that's helpful, something that we can use with our special right triangles. Okay. So there's several ways you can do this. Let me show you one of the other ways. If we do pi over 12, let's see, we can do more subtraction here. Let's see. You know what? Let's just stay with what we have here. Sorry, I think I was thinking of a different problem. Okay, done and done. All right, so now what we're going to write is we're going to say we want the cosine of pi over 4 minus pi over 6. This is equivalent. Remember, we said this difference is the same as this. We just reduced it, which is exactly the same as 1/12. Okay, so we're using our cosine identity with a difference. So when we do this, it says cosine of, remember this is A and this is B, cosine of A, cosine of B, and since this is a difference in this identity, we use a plus. Okay, so it's really important that you follow that. And then this is going to be sine of A, sine of B. All right, now we evaluate. This is radical 2 over 2. Then again, we're looking at that special right triangle, right? Pi over 6, pi over 3, 1/2, radical 3 over 2. Cosine of pi over 6 is going to be radical 3 over 2 plus radical 2 over 2 is that sine of pi over 4, and sine of pi over 6 is 1/2. So we get square root of 6 over 4 plus radical 2 over 4, and we go ahead and combine the fractions. Radical 6 plus radical 2 over 4. And that's our exact answer. So again, you might start with something like this and say, oh, I don't know, I can get a decimal approximation, because I could still type that in the calculator. But if we want an exact answer, these identities are the way to do it.